All right, back at it with another video. So we're going to go over characteristic of function graphs. Again, you can print this and follow along. It's on my Canvas webpage. So the objective will be that you will be able to identify the following characteristics of a function from its graph: domain, range, end behavior, maximum, minimum values, increasing, decreasing intervals, positive, negative intervals, and zeros. So there's a whole lot going on here. We're going to start with a bunch of definitions, and then we'll do look at a couple graphs and see if we can't put all the pieces together. So we'll start with a definition of increasing. What does it mean for a function to be increasing over an interval? So I gave you the mathy, very hard to understand definition because I want you to see it, and I want you to be able to someday hopefully read these things and interpret what they're saying. I will translate it into plain English after we have a little discussion on what it's saying. So a function is increasing on an interval if f of x1 is less than f of x2 when x1 is less than x2 for any x values x1 and x2 from the interval. So that probably made your eyes cross. So let's draw a little picture to see what's going on. So let's say this is our function. Okay? So let's take two arbitrary x values. Let's call this x1 and x2 because in our definition it said that x1 has to be less than x2. So that means x1 has to be on the left of x2. All right? So they will have corresponding y values. Okay? So the corresponding y value of this first x value called x1 we'll call f of x1, and x2 is going to have a corresponding y value of, let's call it f of x2. So that's the output when at x of 2 or x sub 2. This is the output at x sub 1. So what this definition says that is that if f of x1 is less than f of x2, then that means your graph is increasing over that interval. So that means that from here to here, we call this graph increasing. So you might say, well, isn't that just, we could say that it's rising from left to right? And I would say, yes, you understood this definition now. Okay, because that is the plain definition, and that is what I'm going to write on the other piece of paper. So the part that says in English, please, I'm going to say the graph is rising from left to right. So in math, we always read a graph from left to right. The only caveat to that, or the only catch to that, is end behavior. In end behavior, we kind of do read right to left when we're looking at the end behavior as x approaches negative infinity. Okay? Now, the definition for decreasing is exactly the same except for one key symbol, and it's that one right there. It's saying that f of x1 is greater than f of x2. So you can kind of picture from the previous page that if this point is lower than this point, then your graph has to be going down. So that's the translation that we're going to use. We're going to say the graph is falling from left to right. There we go. Get it to focus. So, as a key note, when describing increasing or decreasing intervals, we always write the x values for which the function is increasing or decreasing. So, what I'm going to do is go to the second page, and let's look at, we're going to go through all of this eventually, But let's just talk about the increasing or decreasing intervals of this function here. Okay? So, let's write here, I'm going to write increasing. Down here, write decreasing. So, you should notice that this graph does both of it, because if we're going left to right, if you put your pencil on this graph and kind of trace it, what's happening as I move my pencil from left to right? Well, it's falling. So what did we just say that was? We called that decreasing. So it's decreasing. Where is it decreasing from? What x values? Well, this graph goes forever and ever to the left. So starting from forever and ever to the left all the way until -3, we find that this graph is decreasing. So how would we write that? Well, that interval is going to be from -infinity to -3. Okay, now the question is, do we put a bracket or do we put a parenthesis here? Well, at this point right here, this is the lowest point. It's neither increasing nor decreasing at exactly this point. Okay, when you get to calculus, you'll get the idea of what it actually means in application for exactly at this point. But for this class, all you need to know is the point where it turns from decreasing to increasing, it's neither increasing or decreasing exactly at that point. So we're going to use a parenthesis to say it's not included. So where is it increasing? Well, if I continue my pencil, so we're here, after that point, if I trace the graph, I'm rising, so that would tell me I'm increasing. So I'm increasing from -3 to infinity, forever to the right. This infinity is not a y value. This is saying from -3 to positive infinity, over these x's, the y values are going up, and from -infinity to -3, the y values are falling as you move left to right. So that's increasing, decreasing. Okay, let's go back to this page. Let's talk about maximum and minimums. So maximum values are y values that are the biggest in the function. Okay, these occur when there is a change from increasing to decreasing. So let's think about that. If I was to draw a small little picture here, if I change from increasing, that means rising from left to right, to decreasing, which is falling, this point right here would be a max. Okay, it creates a hump. Is another way to see it. Okay, on the opposite of that, minimum values are y values that are the smallest in the function. These occur when there is a change from decreasing to increasing. So we start decreasing, change to increasing. That change causes a minimum. Okay, and when we describe the max and mins, we just put the y value. It's talking about the max or min for that function. Okay, as a couple notes, maximum and minimum values can never be infinity or negative infinity. They must be a concrete, exact number. Okay, so when we say a function has a minimum of 5, we are saying the y value is 5. There is no information about x values when stating a max or a min. All right, so let's look at this graph again. So we have a change, if we're going from left to right, we have a change from decreasing to increasing. So, as stated in the definition, that should create a minimum, and that's what we see here. So, what would that minimum value be? Well, it wouldn't be -3 because there's x values that are lower than that. And plus, when we're describing max and mins, we're describing y values. So the lowest y value that this function takes is -2. So all we would do is say that there's a minimum -2. Okay? All right. The last new piece of information, well, second to last, I guess, is positive versus negative. So a function is positive at all x values for which y is greater than 0. So how can we translate that? What does it mean for a graph to be greater than 0, for y to be greater than 0? That means above the x-axis. So in order to be positive, we have to be above the x-axis. Okay? A function is negative at all x values for which y is less than 0. So to be negative, below the x-axis. So when describing where a function is positive or negative, we use x values to describe the interval. Okay? So if we look at this graph, here's the x-axis. So we kind of have two places where the graph is above the x-axis. We have it here and we have it here. So we're going to have two intervals that we need to describe. So I'm going to put it's positive. Sorry, let me move that over. Where is it positive? What x values? Well, it's positive forever and ever in this direction. So from -infinity to -4 is where it crosses the x-axis. So where it crosses the x-axis, it changes from positive to negative. So my positive interval is -infinity to 4. Now, it's also positive over another interval. And that interval starts at -2, because that's where it hits the x-axis, and goes forever to the right. So the way we write two intervals, we're going to use this symbol. It's like a U. It stands for the union, and it just means that these two intervals together are both positive. Okay? So we're positive from -2 to infinity. Okay? Again, these are x values that produce positive y values. So if we were to take the ordered pair at a number, say, at 5, and I wanted to know an x value of 5, and I wanted to know, well, what's happening with my y there, I can tell you that it's positive because 5 lies within this interval, and I'm telling you that it's positive. If I had a number like, what's the y value when x is -10? I can't see that from the graph. If I didn't have an equation, I couldn't find it, but I could tell you that it's going to be a positive number. Okay, so where is it negative? Well, it's negative if it's below the x-axis, so that's from -4 to -2. And notice I'm using parentheses here. This is an interval. This is not a location. It's not telling us that it's at -4, 2 here. This is an interval. I'm using parentheses because at -4, we're neither positive nor negative. Same thing at -2. We're neither positive nor negative. So there's the interval. All right, so the last definition is the idea of a zero. It's the x value for which f of x is equal to 0. So remember, f of x is the same thing as saying y. So it's the x value for which y is equal to 0. And we know that's a special point. We called that the x-intercept. Okay, so a 0 is the same thing as an x-intercept. So our zeros are what in this problem? Well, it's where it crosses the x-axis, so it's -4 and -2. All right, and there's my zeros. Now you should be able to find the zeros given the intervals where the function is positive or negative, and I'm going to require that in this class, that if I tell you a certain function is positive over this interval and negative over this interval, where's the x-intercepts? That's a good problem, and you'll probably see it in your practice. Okay, so now that we got all the definitions out of the way, let's go through these two examples and finish them up and call it a lesson. So the domain of this, okay, the domain is it's going forever and ever up and to the left and forever and ever up and to the right. So that means it's all real numbers. Okay, so I've been writing the words all real numbers. I am fine if you do that. You could also write it this way. That's the inequality, the set would look like that, and finally the interval could look like that. And I'm just going to write here, you could write all real numbers. Okay, what about the range? The range is not all real numbers because it doesn't go forever and ever in the down direction. So right here's our lowest y value. So it's all y's greater than or equal to -2. So as an inequality, y is greater than or equal to -2. As a set, the set of all y's such that y is greater than or equal to -2. In interval, -2 is our lowest value, and it goes to positive infinity. The end behavior. The end behavior would be as x approaches infinity, y approaches infinity, since it's pointed up on the right side. On the left side, it would be as x approaches negative infinity, y approaches positive infinity. Okay, now this next question is a little interesting because it says, what is the range of the function if the domain is restricted to -3 and 0? Okay. You know what? Let's change this because I can't see what the y value is when x is 0. So let's change this to -2. So if I restrict the domain to -3 to -2, what would our range be? So restricting just means I'm only looking at the part of the graph right here. So that's our new graph, just right there. So what would our range be? Well, the lowest value is the same as the previous function. It'd be -2. And then it goes up to, it stops here, so it goes up to 0. So -2 to 0 would be the range. Now, since -3 was included, that means that -2 is included. And since -2 was included, 0 is going to be included for the y. So this is your range that corresponds to that domain. Okay, last example. So, domain. This domain goes forever to the left, forever to the right. We know that is all real numbers, so I'm just going to write the words on this one. I'm out of space, so I just wrote the symbol for numbers. I'll put little quotations there, meaning you can write that there. What about the range? Well, the range is not all real numbers because it doesn't go forever in the positive direction, in the up direction. So it has a max here. So in inequality notation, I could write the range starts from negative infinity and goes to 0, included. Sorry, I'm not focusing. Focus. There we go. Okay, or you could just write y is less than or equal to 0 and not have the negative infinity. I'll accept both of these. This is probably more correct, but that's still correct. Okay, in set notation, it'd be the set of all y's such that y is less than or equal to 0. And then in interval, it would be negative infinity to 0 with a bracket because 0 is included. The end behavior would be as x approaches infinity, y approaches negative infinity, since on the right-hand side it's going down here. And then on the left, as x approaches negative infinity, y is also going down, so it'd be negative infinity there. Okay, the maximum and minimum, we have a max of 0. Okay, increasing or decreasing intervals. Well, I see two things going on here. I see from left to right it's rising and then falling. So it's increasing from negative infinity. Remember, these are x values. So we're going forever to the left up until the point -1 on the x-axis. It's increasing, and then it's decreasing from -1 to positive infinity. Now, what a lot of students make mistakes on is they think because the graph's going down, this should be negative infinity. But remember, we're describing x values. The x values are moving to the right, which is in the positive direction. Okay? So where's the graph positive or negative? Well, I can tell no part of the graph is above the x-axis. It's all below. So does that mean I write negative infinity to infinity? No, because at this point right here, it's on the x-axis, and that point is neither positive nor negative. 0 is neither positive nor negative. So that means it's negative. Remember, we're still writing x values here. So it's negative from negative infinity, as far as you can go on the left, to -1. And then there's another set starting at -1 and going to positive infinity. So why did we write it like this? Because this is interesting. Well, what this notation says is -1 is not included in this interval, and -1 is not included from this interval. So I can deduct from that that -1 is on the x-axis because it's neither positive nor negative. So what are the zeros? Well, the zeros, I can get from my positive and negative intervals even without the graph. My 0 is -1, 0. Okay. The question again is, what is the range if the what is the range of the function if the domain is restricted to -3, 0? Okay, so you'd only be looking at that part of the graph. Sorry, the camera's freaking out. Okay. So, what are the y values that correspond there? Okay. Well, maybe I can do this. It'd be a little... What are the y values there? Well, the lowest y value is -4. And it's included because -3 is included in the range, or in the domain, excuse me. And then 0, the y value that corresponds is -2, so it's going to be from -4. Be careful, I almost made the mistake here. We don't always look at the endpoints, do we, when we look at the range? So even though it starts here, that's not the highest y value. The highest y value is actually up here at 0. So the range would be -4, 0. Be careful. I even get caught on that sometimes myself. All right, so sorry this video is so long. There's a lot going on here. And feel free to skip forward if you want to see answers to things, but definitely know these definitions. Talk to you soon.